Hello guys, my name is Engineer. We want to look at this second question that has to do with some technical question about temperature and heat measurement. This one says the resistance R of a copper wire depends on temperature T via the equation R is R ordinary R equal to R naught open bracket 1 plus alpha open bracket T minus T naught close the bracket or what closed, where R naught is the resistance at temperature T naught, that means initial temperature. If don't forget T is the final temperature. Now that means they use resistance if resistance changes, temperature changes for this question, where R naught is the resistance at temperature T naught. Now, if the resistance increased by 10%, find the corresponding change in temperature. Now, let's say that what R final equal to R initial plus change in resistance. Recall that L equals to L naught plus change in L, meaning because change in L equals to what? L naught, L final minus L initial. Similarly, this one will also be what? Change in R, now be what? R minus R naught. That means final resistance minus initial resistance. Now, they say the what? If what? The resistance increased by 10%, that means of the initial, that's what they mean by that. 10% of R naught, which is saved as what? 0.1 R naught. Therefore, the final R should be what? R naught plus what? 0.1 R naught. And that will give us 1.1 R naught. So this is the final resistance now. The final resistance at T. Now, why the word R is what? Initial resistance at T naught. Now, what do we do? Put it here. So I would have 1.1 R naught equal to R naught into like a 1 plus alpha change in temperature. Now, since it is copper, take alpha of copper to be equals to what? 1. Okay, let's say 3.8. I give you 3.8 times 10 per minus 3 degrees Celsius per degree Celsius. Now that is the word given for copper. So in that, if that is given for copper, which is alpha for copper, we put it there. We would have 1.1 R naught equals to what? R naught 1 plus 3.8 times 10 raised to the power of what? Minus 3 T minus T naught. So what do we have? Let's make T naught the subject of formula. First of all, this one can cancel this one. So I will left with 1.1 equals to 1 plus 3.8 times 10 raised to the power of minus 3 T minus T naught. So let's take this one here. I would have 1.1 minus 1 equals to what? 3.8 times 10 by minus 3. I get T minus T naught. So we are going to have it as well. This one will give us 0.1 equal to what? 3.8 times 10 by minus 3 T minus T naught. It's T naught, please. T naught. I will clean it. So if you have T naught here, then what do you have now? We make this one the subject of formula, because T minus T naught is what we call the change in temperature. So in that case, we are going to have it as what? C minus, if you divide both sides by what? 3.8 times 10 to the power minus 3. 3.8 times 10 to the power minus 3. So what do you have? We are going to have it as C minus T naught equals to, this one will cancel this, 0.1 over 3.8 times 10 to the power minus 3. So what we're going to have now is what? 0.1 into bracket what? 3.8 times 10 to the power what? Minus 3. So we should be having what? 26.315. 26.315. Approximately what? 26.3 degrees Celsius is temperature. Let me just add one more to it quickly. This one says a platinum wire has resistance of these 2.56, 3.62 and 3.15 respectively at 0, 100 and 55 degrees respectively. So calculate the difference between 55 degrees Celsius and the current what and the corresponding platinum what resistance, our platinum temperature.